Hello, good morning. This is Jeff McGinn. Hopefully everybody can hear me. We had a little bit of a technical glitch, so I will move very quickly through the content. But I want to say thank you very much for your time. I want to thank you very much for the invitation to speak to you. And I want to talk a little bit about this title first. So we talked about breaking the obstacles to healthcare ecosystem analysis. And frankly, what I mean by this is that in some areas of healthcare, AI and ML techniques have been used, but not used to great effect, right? In life sciences, which would be like biotech, biopharma, I think they've probably the most advanced. But in many parts of healthcare, it's still kind of a system in flux. And we're going to talk about some reasons why that is, and we're going to talk about some remedies to it, right? And one big reason is that the analytics business, when it comes to healthcare, is in flux. Right. There's two sociological mentalities going on. And the first one is kind of an old school actuarial approach to looking at things, which is kind of like I would call intuition verification, where you're using hypothesis testing, using multivariate methods that are in some ways very static. And I'll define static in just a moment. The bias there is it is limited by how good the intuition you're testing is, right? But as I said, this business is moving in flux, and it's increasingly towards what I will call intuition agnostic modeling. And that's the AI ML approach. You take the data you have, you find intrinsic relationships or patterns. There is a bias there as well. And the bias is this is very sensitively dependent on how comprehensive your data is, right? Here's what the C-suite wants, regardless of mentality. Right? You may have to talk to people about getting clusters and S3 buckets and storage and cloud compute. But what the C-suite wants to know is, help me know what's going on, right? They want to know before anyone else does. What they mean by that is they want models that can signal operational or conditional changes before they either hinder or help processes or people in the following ways, right? They want to modernize care infrastructure. They want to improve and accelerate diagnosis. They want to increase customer engagement. They want to improve care delivery and manage population health, right? Very standard models. And what I've got here is what I think of as the scientific method adapted to an AI ML workflow, right? I'm not going to talk about asking the right questions. That's trivial. I'm not even going to talk about how to communicate impactful decisions, as important as that is. I'm going to focus on the red letters here. Finding the right data, why that matters, and using optimal methods to apply to it, right? I'm going to gloss over this slide. It's a bit complicated, but it highlights something really important, right? Why do models work? Well, the world is somewhat predictable, right? If you drop ice cream, it's going to land on the pavement and not float up into space, right? But even within the predictable world we live in, there is intrinsic uncertainty. And I quoted Heisenberg here, not the Breaking Bad guy, but the physicist who created something called the uncertainty principle. And he basically said, we cannot even observe the precise current state of a single electron, let alone the universe. Static models don't work well with intrinsic uncertainty. They don't work well with extrinsic uncertainty either, right? The solution is really the triumph of AI and ML models. It's learning and proper training of algorithms. Because yes, we live in a regular universe, but up to time t current, there's many possible continuations, but life tends to find the lowest energy eigenstate. So what you really have to do is you have to think very carefully about data and comprehensiveness and timeliness and coverage and in context, because that's going to give you what the C-suite wants. Models that signal changes before anyone else knows. That's the value proposition, right? I'm going to start generalizing, and we will go quickly through this again, but I want to highlight that a business rule is really just a data rule. It's only as comprehensive as your data, and I'm going to give you an example of this. Not too long ago, I wrote a paper, actually it was a while back. I wrote a paper, and within that, I basically said, in conclusion, the interaction between an activated patient and a proactive physician is where the sweet spot happens in good outcomes and good care. But it's difficult to observe and measure. You can't evaluate hypothesis about this in any easy way. And I've spent many years trying to address this. And I've done that to some extent, right? In healthcare, typically people use claims. It's an invoice and it tells you a lot about the provider. You've got to move beyond claims if you want to understand the patient. Hence, I have become a real big believer in social determinants of health data. Data that is not census-based, but data that is based on ad tech technologies that segment populations based on ethnic, financial, educational, and behavioral factors. And you're integrating this data together using, I guess, Splink or Levenstein distances, identity resolution in the truest sense, right? And you're doing it in a way that respects HIPAA compliance. I probably won't have time to talk too much about HIPAA. I'm thinking if you're in healthcare, you know about it already. So I'm going to move beyond that and ask, why does that really matter? And I'm going to give you an example here. Within chronic disease management and diabetes management in particular, CMS has said A1C should be managed for non-pregnant adults to less than 7%. It's a reasonable goal, and I understand why that's there. But there were a lot of dissenting views from providers and physicians because they started saying, what I observe if I aggressively target my population of diabetes patients to be under 7, often they're impaired to the point they can't drive a car, right? So what we really need to do is employ and deploy AI in what it does best. Personalized, targeted, optimized care processes that can integrate all these ethnic, economic, and behavioral factors, right? I got some quick links down here. I'm happy to share these slides as needed. Here's what it looks like, right? This is an example of hospitalizations for people with diabetes getting an insulin infusion. And these are racial categories indexed to census, right? You see that race is an important factor in diabetes-related hospitalizations. You can over-index or you can under-index. These populations mean an immense amount to understanding what a 7% target can really mean. And there's more. This is just another example, but the example here is to highlight, not does it shed light, but that the relationship is very understandable. And if I can put a relationship of education into a chart like this and show such a nice linear relationship, imagine what a more sophisticated model that combines a number of different factors can do. This is another example of what economics can do for you. I have an economic stability index overlaid on top of hospitalizations for diabetes. And the problem that you see is if you ignore these kind of factors, there's going to be a major knowledge gap in your models. You may not be able to indicate exactly what's happening until the C-suite what they want, right? But final point on this before I go to the next chapter. 80% of our health and well-being is affected by social determinants of health, things that happen outside the doctor's office. Your health literacy, how well you sleep, your exercise, country of origin, financial stability, all these factors really matter a lot, right? The next chapter, data latency, machine learning, and what I will call impact decay, right? So we've talked about the need to really be comprehensive in scope. Now we need to be really good in terms of timing, right? As I said, C-suite's always asking what is happening and tell me what's going on. In March and June of 2020, last year, COVID was shutting down big chunks of the healthcare ecosystem. Elective surgeries were being canceled. Specialists were saying, just don't get this care, right? The point of timely data enables you to find the crisis points and the bright spots. Telemedicine, as you see here in the red circle on this graph, showed a huge increase over month on month from January to March, simply because when lockdowns were segregating patients and providers, life found a way to connect, right? You wouldn't be able to see this if you're getting data with a significant lag. Typically, claims that are paid and adjudicated have a weeks or even months of a lag. The data that I work with actually has a data feed that delivers claim filings within 24 hours. So I can see things as they happen, right? If you're looking at analyzing a situation like this with lag data, what you end up finding is you're driving in the rearview mirror, right? There is a normal that works really well given the static model, and then you have a tectonic shift that happens very, very fast, right? These are patient counts and claim counts for telemedicine utilization over time, right? So not only if you get timely data can you track the tectonic shift, you can actually see, does this trend have staying power? Is it plateauing? What is going on and how is it changing, right? You can apply a lot of techniques and technology to this, but the real essence of timely data gives you a lot of impact, right? I want to talk about one other quick thing, and that is healthcare, not only granularity and timeliness, but context, because the average misleads in healthcare in a big, big way, right? This chart that I have over to the right shows the average allowed amounts by radiologists in a given area over time, right? And what you end up finding for an abdominal MRI is that there is a huge differential in cost. And power laws like this abound in healthcare. There can be pockets of utilization that can be potentially very low or very high, but they're an outlier in terms of cost, right? Analytics needs to be fueled by data that can capture the scale and the scope of an entire ecosystem. And to do that, you have to really think about how to best create panels and cohorts that you can use in your training algorithms, right? And this just summarizes that. Nobody has all the data. You can't pretend to have all the data. So what you really have to understand is what's the best way to create panels? What's the best way to normalize data? It's crucially important for models because if you don't normalize, you have unknowable gaps, and that always leads to spurious correlations, right? If you know the gaps based on the context of the data or the network that you're working off of, you can normalize well, and you can say back into a retail sales figure and impute the top line or maybe even the bottom line margin, right? Third-party data sources have at best limited insight into this, so you have to be very selective and choosy about the data that you have, right? These sort of paneling and normalization tools and techniques, I think are really a great way forward, right? It's the right platform for healthcare AI ML has to do with that HIPAA compliance framework, right? And I'm not going to belabor this because I know a lot of you guys are within the healthcare environment, but it's important to understand if you're going to integrate a lot of social determinants of health data to augment your model, you're going to be creating re-identification risk within it. And you're not going to be able to do models of this type where you're going to do new entry analysis because you can't track that small a denominator to see if it's going to become a blockbuster drug or if it's going to plateau or even the drug will not be well received within the marketplace. You have to look at utilization trajectories. And in order to do that, you have to have it in a secured environment, right? It's the basic gist. One other thing to talk about here in terms of having secure data, it will allow you to work with denominators that are very small. So you can work with a system of data that evolves over time. Because the evolution of the picture that you're looking at, if you have timely enough snapshots or extracts, it's no longer a picture. It becomes a moving motion picture. And that's a pretty powerful way to look at this data. So I'm going to stop sharing real quick. And I will just quickly do that. And I tell you what, if there's any questions or comments about this, please feel free and chime in. So I will deliver my email address into this. Feel free and reach out if you'd like to have these slides. And also feel free to reach out if you just have any questions about this or want to go into even more detail around it. So thank you very much for your time, and I appreciate it very much. See you later.